In video 83, I go through some details. I suggest reviewing that video before watching this video, but essentially in video 83, I show that some of the matrix operations we do are needless. Let me do a brief review here with our three-dimensional matrix. We have values A, B, C, D, E, F, G, H, I, and what these values do and how they modify a vector. I'll just say V1, V2, V3. In fact, actually, I probably shouldn't do this, but because vectors are more mathematical than what I'm doing here. But we basically have an X, Y, and a Z component, or an I, J, K would be the vector way of saying things. But if you remember G and H from that video, these are always 0. Let me get a different color here. These are always 0. Alright, and I is always a 1. Okay, well, when we take this row and we line it up with this vector, we essentially do 0, 0, 1. And multiplying by 0 is the same as doing nothing. And multiplying by 0 is the same as doing nothing. And since we did nothing here, we don't need to add those, so we don't need to do the addition. And since we have nothing to add from that result, we don't need to do this addition. And multiplying by 1 is the same as just grabbing this value here without having to do the multiplication. So if we have several vertices to process, then we can save a significant amount of time by not doing all this extra heavy lifting. But we only have 3 vertices on our spaceship. But the idea is still the same. So I think it's good, it's educational to go through what I'm about to show you. We're going to make a different version of the Matrix3D that essentially will not store these zeros, and it will not store this 1. So we're going to essentially eliminate that last row. But the visual effect will be the same, because doing nothing is the same as multiplying by zeros and 1 and adding just this value. So we're going to save all this work, but we need to make a different version of the Matrix3D that will essentially eliminate all this. So I think the easiest way, and I might shoot myself in the foot by doing this, you've seen me when I copy and paste code, I essentially always blow my foot or my arm off. Sometimes I even get close to blowing my head off, but I'm going to try doing it here just to save some time. But well, first we should actually write the unit test, should we not? So generally I like to write unit tests. I like to stub out the class and then write a test and just make sure everything's compiling and then implement the class. I just don't like to write a test without having some sort of empty methods or function stubs to test against. But in this case, where I already have some existing code, I'm simply going to copy and paste that. Maybe let's make it at least an attempt to modify our tests, and we'll eventually work towards making this compile. So engine tester will set up as the startup project, and then go in here. You can see, I have my filters turned off. Here we go. Filters, turn back on. Matrix3D tests. And the tests for the new matrix that we're going to build are going to be much like the Matrix3D, except we're not going to have this last row here. Row 2 we are going to eliminate. So some of these tests I can actually reuse to a point. And by reuse, I don't mean copy and paste. Well, we will need to do some copy and paste. But let's try to keep that to a minimum. So first of all, we make this identity. And then we do this. I'm wondering, what's the easiest way to go about doing this? Let's my issue is we're eliminating this last row. So we're going to eliminate that row, and we're going to eliminate that, and we're also eliminating this. And I've tried to see if I can find a clever way to factor this a little bit, because I hate to just copy and paste it, but maybe that's what we're in these construction cases, I think that's basically what we're going to have to do. And oh, that hurts me. If you can think of a better way to do this, and you put it in the comments, and don't just put it in the comments and say, hey Jamie, there's a better way. Actually do it and see if it works, and then if it really works, then yeah, put it in the comments. But otherwise, just don't think of something and throw it out there. Well, I was going to write a separate test for Matrix2DH, but I think what we'll do is just this hurts so much. Control C, Control V, and instead of saying Matrix3D here, I'm going to say Matrix2DH. Right, the H is for homogeneous, right, and we will define this class shortly. But essentially, everything about it should be the same, except there's not that last row. Let me grab this, put this here, put that there, get rid of this last row, and get rid of this last row test, like so. Now rotation, if you notice, rotation on our matrices, if you go back to the rotation videos if you need to, but we have this like 3x3 kind of thing. But with rotation, we only use the upper left 2x2. Okay, the reason we even made the three-dimensional one was to throw translation right here. So I believe rotation doesn't use that last row, and it doesn't look like it does. So I think in this case we can use C++ templates to solve this problem. So void test rotation. If you don't know templates, please go look at the templates, C++ templates video pieces in the C++ playlist. I'm just going to grab all this code. Wow, we wrote a lot of code, didn't we? Okay, but I feel good. That's a lot of good tests. Control X, put it right here. Control V, Control L. Alright, now we have this template rotation. The thing is, I want to change this type. Right? In one case, I want it to be Matrix3D. Let's keep testing our old Matrix3D. And in other cases, I want it to be Matrix2DH instead. So I want to change this type. I want to parameterize this type. Now we're used to parameterizing values. We pass values in and parameterize them all day long. Okay, these values are parameterized and that kind of thing. Or we're used to function parameters, but now I want to parameterize the type. I want to change the type. In one case, I want it Matrix2DH, and in another case, I want it Matrix3D. So that's where our templates come to the rescue. Template, class T, and now everywhere I say Matrix3D in this selected area, let me just select all of this. Basically, anywhere I say Matrix3D, I want to say T. So Control H, I want to replace it with a T, match case, match all word, replace all. 8 occurrences found. So you can see here now we have this T, and essentially with templates, if you remember or recall, with templates, everywhere the compiler says it sees T, it will replace that T with whatever we pass in for the generic argument. So let's actually do this. I'm going to collapse this and say test rotation using Matrix3D, and then test rotation Matrix2DH, which we will define shortly. So hopefully you can see we're kind of, the angle brackets almost look like a regular function call, but instead of using parentheses like we're used to using parentheses, we are instead using angle brackets and passing in a type. Right, now the type is resolved at compile time, not runtime. With function calls, generally and almost always, these, when we pass parameters, they're evaluated at runtime, and there are certain conditions where the compiler can evaluate them, but not many. But in this case, the compiler will always evaluate the argument here, and essentially everywhere it says T, just replace with what we pass in for T, which in this case is Matrix3D, and this one is Matrix2DH. Now the 2DH, even though we're eliminating the last row, it should still handle translation just fine, and I believe we can do the same with this code. So let's do void test translation, like so, and again template class T, and let's grab all this, Control X, Control V, highlight, Control KF to format it. And again, Control H, replace Matrix 3D with T. Please replace all. Sounds good. And then here, let's test translation using Matrix 3D. And then let's test translation Matrix2DH. Okay, good. Matrix vector multiply. Well, again, here we're using that third row. The results should still be the same, but we're using the... Well, the result actually won't be the same because we have different values down here. So we're going to have to customize this test just a wee bit. Let me, first of all, copy this. And we shall paste it down here. And bring this back. And again, say Matrix2DH. And then I'm also kind of breaking another rule of my test-driven development. And that is I'm basically writing all of the tests for a unit. Right? And when you first hear test-driven development, it sounds like it's just exactly that. Write the tests and then write the code. Well, no, what it means is write a little test, write a little code, write a little test, write a little code. And I've shown that in several previous instances where we've used test-driven development. But in this case, I'm just hack and slashing here and writing or implementing all the tests. And why? Because I'm in this mental mode right now where I just need to modify all the tests for a Matrix2DH. So probably not the best idea. I should probably just do this one by one and implement it and make it work. But even Jamie King doesn't follow his own rules. Alright, I just eliminated that last row. Vector 3D should be good. Multiply. But now that I've eliminated that last row, these values are going to change. So I think just for my mental sanity, it might be easiest just to work it out again. I could work backwards. In fact, why not? Let's work backwards. If you remember, basically this value is made up of a 1. Oh, God. Let's just draw it out. Okay, we have a 1, 2, 3. That's a 3. 4, 5, 6, 7, 8, 9. That's this matrix here. We're multiplying it against this vector. So to get this value here, we overlay this row over this column, multiply and add, and that gives us that value. Well, with the Matrix2DH, we're still going to have this row, that's fine. And we're still going to have this row, that's fine. But we're no longer going to have this row. Right? We will eliminate this row. You can see I've already eliminated it down here. So that will change the result of the last value right here. We won't have 7 times 1 plus 8 times 2 plus 9 times 3. Instead, we are forcing this to be a 1. So it's really 1 times 3. So our last value here will be a 3. So let's just clear that off, get rid of all that, and we'll put a 3 right there. And we're going to call this op2 because we already have an op right up here. So op2. I think that's probably good. I was debating on whether to change the name to M2DH op2 or something, but I think the function is small enough that we can tell what's going on here. Matrix 3D matrix multiply. Well, again, same thing here. We need to eliminate the third row. So copy this. Oh, this hurts. Paste it down there. Back this up. Matrix 2DH, Control C, Control V, no longer have this last row, so how's that going to change the result here? Well, essentially it's going to change the results of the last row. Okay, the last row, well, we don't even have a last row, so we'll just get rid of that. Alright, that should be good. So in some cases we were able to factor, and we were able to reuse some tests using templates, but not all cases. In the translation case we were, in the rotation case we did, but not in the others. Alright, I'm going to not even try to build this, but I will hit Control Shift S to save the file. And this video is getting long. In the next video, we're going to actually essentially copy and paste our Matrix3D class into eliminate the 3D-ish stuff and make it into a 2DH stuff, and break some rules there, because we're kind of, if we do it right, then the test will in theory just pass, and we haven't failed any tests before passing them. And oh, I'm breaking the rules, but I've been pretty diligent of keeping the rules with test-driven development. And in this case, do I feel like I'm justified in breaking the rules? No.